was standing on the corner when I heard my two dogs bark. They were barking at two men who were gambling in the dark. That was like a leap and believe. Two men who gambled late. Stackley chose 7 and swore that he drew hate. Stackley told Billy, I can't let you go back. You done won all my money and my brand new Stetson hat. Stackley went running down the lonesome railroad track. Say I don't kill it, Billy, but don't be here when I come back. Stackley went home and he got his fort.
That was one of the greatest Jamaican musicians, I think, maybe ever, Prince Buster, who was very big in England in the 1970s. But I listened to him very much growing up. Thought I would share that with you guys. In any event, we have up here a bunch of radicals that are not square roots. Okay, so you're used to seeing a square root, and these are other varieties of roots. The little number up here is called the index. Okay, with the square root, you could write a 2. Like another way to say the square root of like anything like 25 would be to write that, and it equals 5. You know, this is not, typically written. It's usually not written. These mean the same thing, all right? But the number up there tells you how many times you've got to multiply something by itself to get this value, all right? So like the cube root of 25 would not be a rational number. Nothing times itself 3 times could give us 25, okay? We couldn't simplify that. All right? Same with the 4th root of 25. This would mean what times itself 4 times would give us 25? Well, it's not going to be a rational number, okay? Now, if this were like a 16, it would be a different story. What number times itself 4 times would give us 16? Well, 2, right? Because 2 times 2 times 2 times 2 is in fact 16, okay? So this is something you just kind of become a little familiar with. You have to know some basic powers, like a 2 to the 4th power is 16, for instance. All right? But on your calculators, to do a problem like this, I hate to say to rely on your calculator, but you should know this, that if you're taking the 4th root of something, you could figure out at certain calculators you can enter that index. You can do that. But in general, it's good to know this. The 4th root, another way of writing this is the 1/4 power. Okay? And the cube root, little 3 up there, would be the 1/3 power, and so on and so forth. So on your calculator, you could just enter 16 to the power, that's what that caret button on the calculator means, parentheses, 1 divided by 4. Okay? You want to make sure that the 1/4 is all in the exponent. Okay? Some calculators automatically, when you hit this, put you in the exponent, so that you don't have to worry about parentheses in that case. All right? But you want to make sure it's 16 to the power 1/4. Enter this in your calculator, make sure you get 2, all right, because that would mean you're doing this correctly. So you could do these weird radicals in the calculator also, all right? So in general, with the rule for this, we'll get into this more in the future, but the nth root of x to the m power equals that number x to the m over n power, okay? So that's why, for instance, the 4th root of 16 was 16 to the 1/4, right? It's like the 4th root of 16 to the 1st, right? So it's 16 to the 1/4 power, all right? That's what it means, all right? This is not really what I wanted to focus upon for this video, but it's a good thing to mention that you can always go back and forth between a radical expression and an exponent if you want to. Okay, you can always do that, all right? Now, getting into some simplifying problems. All right, the cube root of 8. Again, that just means what number times itself 3 times gives us 8. Well, you maybe you'll start to know this very quickly, but the answer is 2. All right, 2 times 2 times 2 is 8. So that's why the cube root of 8 is 2. All right? So you should be familiar with some perfect cubes like 8, 27, 64, 125, 216, and so on. Like another quick problem would be, all right, cube root of 8 is 2, cube root of 27 is 3. Okay, the cube root of 27 is 3. If you're cube rooting a perfect cube, then you won't have any radical symbol left in the answer. Just like the square root of 25 is just 5. The square root of 36 is just 6, right? If you're square rooting a perfect square, there's no radical symbol left in the answer. Well, in the same light, if you're cube rooting a perfect cube, there's no radical left in the answer. The cube root of 64 is 4. The cube root of 125 is 5, because 5 times 5 times 5 is 125. So it's a good idea almost to memorize those perfect cubes. You don't have to know too many more after this. The cube root of 343 is 7. Good one to know also. All right. Now, here's an example of one where 270 is not a perfect cube. All right. So how did you handle a square root? Well, to remind you, a square root of 50, for instance. 50 is not a perfect square. You find a perfect square that goes into it. 25. So we handle it like this. 25 times 2. The square root of 25 is 5. We bring down the root 2. That's the answer. Same idea with the cube roots. You find a perfect cube that goes into 270. Not a perfect square, not like 9, 16, 25. I know you want to. You see the radical symbol, you're thinking perfect squares. Not in this case. The index is 3. This has nothing to do with perfect squares. Okay, get it out of your head. So we don't use a number like 25. We use a number like 8, 27, 64, 125, and so on and so forth. There's a pretty clear one that goes into 270. You might already see this. It's going to be 27. So we break this down into similar way that we do the square roots, 2 cube roots. The product of 2 cube roots, cube root of 27, which is going to be a whole number, times 27 times 10 is 270. So the cube root of 27, well, that's just 3. And this guy just gets brought down. Our answer is 3 times the cube root of 10. All right, so kind of like root 50, square root of 50 was root 25 times root 2. So it's 5 square root 2. Well, this, dealing with cube roots, cube root of 27 is 3. And this, just like the root 2 was brought down, the root 10 is brought down. In class, you often won't hear me say the index. If we're dealing with a cube root problem, I'll just use the word root. Like, all right, I'll say the answer as 3 root 10. You know, I won't always say 3 times the cube root of 10. I'll write that, though. All right? Number 3, the 4th root. Again, that means what number times itself 4 times is 81. You kind of just want to memorize this, although you could punch in 81 to the power 1/4 on the calculator. The answer is 3. And of course, we could punch in 8 to the power 1/3 on the calculator and get 2. 27 to the 1/3 power is 3. We couldn't do that with 270 because 270 is not a perfect cube. So we couldn't just do 270 to the power 1/3 because it would give us a decimal. We have to know how to simplify it. All right? But the answer here is just 3, which you really should just memorize, that 3 to the 4th power is 81. Some other perfect fourths, 16, 256, and 625. They are numbers that have some other number when times itself 4 times gives us that number. So 3 times itself 4 times is 81. 96 is not a perfect fourth, but in the same idea, same way we did problem 2, we use a perfect fourth that goes into 96 to simplify. So just guess on some. I mean, perfect fourths, 16 already, the next one is 81. So clearly the only possible factor would be 16, and it does go into 96 6 times. So although it's a large number, perfect fourths, I mean, 2 to the 4th is already 16. There aren't going to be many options to go into a number like 96. We can't use them. We can't use 25 and 36 and 81. No, those are not, well, no, 81 is. 49. We can't use those numbers. We have to use perfect fourths. So the index tells you which group of numbers you're choosing between, all right? So the 4th root of 16 is 2. So the answer is 2 root 6, root being the 4th root. All right, so same idea as with square roots and cube roots, right? Here we use the perfect cube, 27. Here we use the perfect fourth, 16. 10 minutes? All right. 2 more minutes. The fifth root of 32, that's also just 2. 2 times itself 5 times is 32. So 32 is a perfect fifth, right? Here are some of the perfect fifths. 243, 1024, okay? Because 3 to the 5th power is this, 4 to the 5th power is that. The fifth root of 160, well, 243 does not go into 160. The only candidate for this one, in terms of perfect fifths, is still the 32. Well, 32 times 10 is 320, and 160 is half of 320. So that's going to be 32 times 5. All right? The cube root of, fifth root, right? I bet you caught that. Fifth root of 32. The fifth root of 32 we already know is 2, and you just bring down the other. So it's 2 root 5 is the answer. All right? Just general, or not refresher, but a little intro to how to handle some weirder radicals. And now, handling variables is also going to be a part of this unit, but I don't want to make the video too long, so let's just kind of pause with this, and we'll handle the variables in class. All right? Hope you like Prince Buster and some of these problems. All right? You can stop the video now.